In our next class, we're going to look at multiple representations of motion. And to do that, we're going to start with something that we see every day, and that's a car that's moving along a street. Now, if we were to take a strobe picture, we'd see a car here, and then the next second we'd see the car here, and then the next second we'd see the car here, and then we'd see the car here. And if we want to model that, we would draw the dot with an arrow. Now, here is our timeline, or no, not our timeline, our position line, and it's labeled X, and each one of these dots represents 1 second. And the length of the arrow represents the speed. So the faster it goes, the longer the arrow, the slower it goes, the shorter the arrow. And it also represents the direction. Now, don't understand, we're only dealing with one-dimensional motion right now, so it's either going to the right or it's going to the left. Now, looking further down, as you can see, here is one car that's going this fast, and this car is going faster because you notice that the front of this car is further ahead than the car in the previous model. And again, each one of these strobes represents 1 second. And also notice that the length of the arrow is different. So this arrow is longer and this arrow is shorter. We move down even further and you can see that now our car is going to the left. So we represent that with a dot representing the second and an arrow pointing to the left like so. So that's two representations. One is a sketch of the object that's moving, and the second is a dot with an arrow representing the motion of your car. Now, more complicated representations, you can see here that this car is starting to, on the left, here's our representation that we're going to look at, and it's moving at a constant velocity to the left, and it moves for 1, 2, 3, 4 seconds, and after 5 seconds, notice that there's a dot but no arrow. That represents it's standing still, and it remains still for 1, 2 seconds. And then by the 3rd second, it's moving back to the left. Now, notice that the length of the arrow here is a little bit less than the length of the arrow here. And it moves to the left for 1, 2, 3, 4 seconds, but it doesn't quite make it all the way back because the arrows aren't as long, which mean it's not going as fast. So, our next situation we're going to look at are two bicyclists. We have cyclist A and we have cyclist B. Cyclist A is going to start ahead of cyclist B, and cyclist B is going to have a faster velocity than cyclist A. And they're going in the positive X direction, and they're both going to travel for 1, 2, 3, 4, 5 seconds. 1, 2, 3, 4, 5 seconds. And this is how we would draw it out. Now notice, after 4 seconds, the two are at the same location at the same time. And then after 4 seconds, B goes further ahead and passes A and goes further ahead and gets more and more ahead of A. Now, this is the modeling representation. Now let's look at the graphical representation, and we can see some of the similarities. A has a intercept that is higher up than B. So A, you can see here, is starting ahead of B, and we can see that on the graph right here. B starts at the origin, so that's why we start B at the origin. A has a smaller velocity than B, so A has a smaller slope than B. And also, notice here, at this point is whenever they are going to pass each other. So we have 1, 2, 3, and 1, 2, 3, and this is where the two are going to intersect at this point. Now, we can also continue and talk about the mathematical formula, which is another way to represent this motion. So here we've got x is equal to VA. VA is the velocity of A. It's also the slope of A on a position time graph, plus x naught. Now, A's got an x naught, or y-intercept, because it's not starting at the origin, and you can see the intercept here. B has no y-intercept, and so it's starting at the origin, and so that's why it doesn't have a plus x naught on its equation. But you can still see it's x equals v naught, vb times t. And this is how you do your representations. Let's do an example of multiple representations. We're going to start with this graph, and this is all the given information. And from this graph, we're going to do a motion map, and then we're going to describe the motion in words. So to start out with, we're going to start at 0. So we're going to graph this portion right here, and here's our dot for the first second. And for our first second, we go up to 2 meters, and 2 meters is right here. So I'm going to extend my arrow to about right there, and that represents the first second. The second second is represented at this point right here, and I'm going to draw that again, starting with my dot, and go out to 2 meters and finish at 4. Now, let me change my colors, because I'm going to represent this part right there. Notice that only lasts 1 second, from 2 seconds to 3 seconds. That's only 1 second, and it's not moving. It's staying still. So I'm going to represent that with a single dot. Then I'm going to move back down my graph in this direction, which I'm going to do in green. And notice that is going in the opposite direction, which is going to be going to the left in this direction. And I would represent that again with a dot underneath. So notice it's going underneath. And how far am I going to go over each second? So first second is going to be going from 4 to 3. So here's 4 and here's 3. So I want to draw my arrow from here to here. And I would do that looking like this. Then I draw my next dot and arrow, my next dot and arrow, and finally my next dot and arrow. And that represents 1, 2, 3, 4 seconds. 4 seconds. And we got, starting here, it's 1, 2, 3, 4 seconds, and I'm starting right back where I started from. So looking at both of these, I'm starting here, going up to this position, I'm staying still for a second, and then I'm going to go back at a slower velocity than what I went forward with. Now, to describe this in words, if I wanted to describe this in words, I would say that it is moving right at 2 meters per second for a total of 2 seconds. All right. And actually, then I will say that it stays still for 1 second. And then finally, it moves left at 1 meter per second for a total of 4 seconds. And now I have 3 different representations of the same motion. My graphical representation, my motion map representation, and my description of the motion in words. After you complete the first worksheet, the next worksheet we're going to do is we're going to look at how to graph velocity versus time, which is going to be a little different than graphing position versus time. So what I'm going to start out with is I'm starting with my description, and the description says the object is moving in the positive direction at a constant, steady speed. So it almost doesn't matter what the speed is I can pick any arbitrary speed, and I just put my dot, and I'm just going to pick 2 meters per second just to have something to graph. So it's at a constant speed. Notice that each interval, the speed is the length of the arrow is the same. And way I would represent that, well, what is the velocity? So I'm just looking at the velocity for each one. And the velocity here for my first second is 2 meters per second, and 2 meters per second, and 2 meters per second. So how would I graph that? Well, if I say this is 1 meter per second, 2 meters per second would be right here, and I would represent that by a horizontal line, because the speed's not getting any faster, the speed's not getting any slower, it's staying at a constant 2 meters per second. And that's how I would graph a velocity versus time graph. Okay, here is a position time graph, and I'm going to take this position time graph and I'm going to draw a velocity time graph on the right. So to do that, I first have to figure out, well, what is my velocity on this graph? Well, my velocity is equal to the slope, and the slope is equal to the rise divided by the run. The rise goes from 0 to 4, and the run goes from 0 to 4. 4 divided by 4 is going to give me a slope equal to 1. And it's meters per second because the rise units are in meters and the run units are in seconds. That's meters per second. Now, I draw that out on my velocity time graph, and it's going to be a horizontal line that looks something like that. Now, the reason it's a horizontal line, the velocity is not changing. The velocity from here to here is 1 meter per second. The velocity from here to here, also 1 meter per second, and the velocity from here to here, 1 meter per second, 1 meter per second. And that corresponds to here, 1 meter per second, 1 meter per second, 1 meter per second, 1 meter per second. Remember, we're doing a velocity time graph here, and this is a position time graph here. Velocity doesn't change, but there is a velocity, so that's why we have a sloped line for position time, because the position is changing. However, here, the velocity does not change, and so therefore it stays straight as a horizontal line. Here's our next example, and notice that it's a different shape. We have a positive slope here, and we have a negative slope here, and the slopes have different values. Here the slope is the rise is 2 to 4, that's a difference of 2, and the run is also 2, so this is a slope of 1. On the other half of this graph, the other part, the rise, well, it's going to start at 4 and go down to 0, some 4 right here, down to 0 right here, which gives you a difference of negative 4. And the run starts at 2 and finishes at 4, that's a difference of 2. So negative 4 divided by 2 will give you negative 2 for your velocity or slope. So let's draw that on our velocity time graph. So I'm going to represent this portion right here in blue, and as I pointed out before, that has a slope of 1 meter per second. Okay, and that's this slope right here. And 1 meter per second is right here on our velocity time graph, and we want to draw a horizontal line that goes across, but we want to make sure we don't go too far. because it's only going at that velocity for 2 seconds. So we're going to start at 0 and finish at 2. So that would look like a horizontal line that goes something like that. Now we go to the next part. And for the next part, I'm going to choose red for the color. And I'm going to color this line in red. And what we said before was that this slope right here was -2 meters per second. And that's that slope for the red line. And I would come on the side of the velocity time graph and find my -2 velocity, which is right here. And again, I'm going to draw a horizontal line, but I want to make sure I start at the right time, which starting at the right time is right here, and that corresponds to 2 seconds. So I'm going to start right here at 2 seconds, and I'm going to go all the way to 4 seconds, and it's staying the same velocity. So come over here to 4 seconds, and I'm going to draw a straight line that represents that. And now I have represented my position time graph into a velocity time graph. And you should be able to do that for the rest of the worksheets. Now remember, you want to make several representations. This is graphical representation. You also need to be able to describe what's going on in words. This one has a positive velocity going to the right at 1 meter per second, then turns around and goes backwards to the left at 2 meters per second for a total of 2 seconds. That's how you would describe that motion. And while you're working on this, I'll try to make sure I'm walking around and seeing if you have any trouble. And then we'll check your final answers when you're done. Good luck.